which is something that can produce commands. So, sorry, this is standard when I get going. Like, I keep going over the movie. Okay, let's keep going. So, part 2. So these devices are all, devices according to this code, which means that they need to be able to respond to the message get factories. And then they need to respond with factories that can produce commands that are suitable for that device. Okay. So let's think about the simplest scenario with the switch. Right? When you ask the switch for get factories, what would you get? You would get a collection of a single factory that is a factory that can produce. We have to design this. That can produce powerful. Actually, this is black up here, so let me just powerful command. Which implements command. Right? So, and actually, a command factory needs to. I should maybe put that like that, but yeah. Sorry, now we get confused about UML. I'm not sure whether we should narrow it, but that's the a command factory produces commands. Okay? And so a device. Now, but then similarly, we should say a device, when asked about get factories, can produce command factories. Command factories produce commands. And an example of command would be a powerful command. And then a command has this execute and unexecute structure, right? Where it's like, so that should be part of the interface. So let's say this is command according to command pattern, and then you have maybe execute and unexecute, right? Like do and undo. So the powerful command, of course, needs to implement the execute and unexecute, but the powerful command will be give it a device, and we'll load it with the device, and then we can run exec and unexec. And one powerful command would probably be switch on, and another one would be switch off. I get a bit confused now. Let's think about this. Of course, we said powerful command here. It needs to be on-off command, or it needs to be an on command and it needs to be an off command, right? So let's think about this. An on command, so here we necessarily get a structure. So sorry, it's going to be a bit small here. I hope you can actually see this. Here and then. Yeah, okay, so a command could be, let's say, let me put two things here, right? 1 and 2. One is on command, and another one is, actually, let me not write command here because I'm just running out of space. So let me say on here, and then say off here. Okay? Those are both commands. But the interesting thing is, of course, that those are not just commands, but they are actually powerful commands. And powerful commands are commands. Okay? This is important because all powerful commands will be loaded with something which is powerful. So powerful commands can operate on powerables, right? And then we'll have a set of temporable commands which can operate on temporable, and a set of colorable commands which can operate on colorable. And it's this confusion around like the commands and the what is it? This connection, or this incompatibility between some commands and some devices. Like you can't send let's say a colorable command to refrigerate like that. Like, it's not that that's fine, we'll just do nothing. I mean, you could do it that way if you want to go like a visitor pattern out. Could maybe do that. But it also, you also say it just fundamentally doesn't make any sense. Right? It's just like it's non-applicable. Like it just shouldn't happen ever. Right? So like such a system shouldn't be constructible. It's an impossible state. So instead we have to divide. We have to divide. There's a set of powerful commands, there's a set of triple commands, and so forth. Right? And the key concept on it, when it's the powerful commands, they operate on things that follow the powerful interface. The temporal commands operate on things that follow the temporal interface. There is no need for anything that's temporal, powerful, and so forth. And of course, how we then get such a set of commands, how to construct such a set of commands, would be by asking a particular device for the factories that are relevant for that particular device. And I say factories in plural, I say factories in plural because we have this division where we don't want to say, we're sort of dividing not by type of thing, but by capability. So we're trying to avoid having to repeat the notion of powerableness across all the different powerable devices, and instead say, well, something can be both colorable and powerful. These are two different things. Right? So then, the refrigerator, or let's say the lamp, for example, is both colorable and powerful. So if it's both, then we need to get two factories. We need to get a factory that produces colorable commands, and we need to get a factory that uses powerful commands. So, the question is, like, what is actually this factory? Like, what is a command factory? And it's pretty interesting. It's pretty interesting. If you think about this as an application, as a mobile application, maybe the command factory is the interface. Is the interface where you're controlling like a slider, or this is the when we're talking about powerful commands, where does the user toggle on? Maybe that's the command factory. So maybe a concrete command factory, a powerful command factory, is the one that helps you, like it allows the user. It affords interaction with the user, and allows the user to interact with it. And when you press on and toggle on, then it produces a powerful command, and executes it. And when you toggle off, it produces a off command and executes that. So. And yeah, I think you can also see how that scales across all of these things. Then you have a command factory for temporal and one for colorable. And the beautiful thing about this, right, is that you can then put, again, you can forget the type information, you can forget the subtype information within the application, and put all of the different command factories for a particular device within the same section, which means you can display it. Right? So you can say, okay, well, this room consists of this bunch of devices. Oh, sorry, you can do this device. What's going on? The room contains a bunch of devices. You say, okay, well, room, give me all the devices. Okay, now I have a question. And then you call the factories. Or then you say, let's let the user click on one of these devices. So the user clicks, there's one on the left. So the user clicks on the left. They're in different views. They're now in the left. And that's the device. That's the display. And that's it. You have location because you particular class. It's going to say there's a one-to-one relationship between this class and different class, which is they're displaying this relationship. And maybe then you would look into something like the bridge pattern, for example. Check out that video if you want to learn that. So that's really going to be device in this way. But the question is, how do you control the device? So then we call the factors, and you get a list of factors that are all under the command factor interface. So then you display these interfaces, and those are a bunch of commands, right? Or sorry, a bunch of command factors. And of course, they would be called command factors in the application. They would be called power, like color, heat, and so forth. Okay? And maybe you even aggregate the concepts of them and put them in this list. So you get like a dashboard where you can control patterns and build color en masse. But then the command factor is displayable. So when you display that, and then you get a bunch of things that you can do. Change color somehow, right? Pick different colors and color all of that, for example. And when you do that, right? When you do that, the command factor will produce a command, right? Know what command is the device from which the command factor is taken. So there's that instruction that somehow needs to be sold. So that's when the device is instantiated. Command factor needs to pass itself to command factor. So the command factor knows what device is taken by the command. The command then is created and potentially immediately by the factor executed if that's the one that you want. It can immediately executed. And if that command then happens to be a powerful only command, when you interact with a press on, for example, when you have an only command, when that's executed, the signal sort of falls back or follows back into the device, which happens to be a land, and the land is switched off. Right? So I think this is actually pretty presentable for the device and the thing. Right? And it's very general. Right? You can probably see, like, it might feel like this is over-architected. But really don't think it's over-architected. I really think it's actually, we could probably go further and increase abstraction more when we start talking about, for example, the UI. But something along these lines probably makes sense because you are now able to treat many different things as if they were the same when their particular details doesn't matter. Right? The abstraction, okay, right? The abstraction is as appropriately identified by you. Right? The abstraction is commands. The abstraction is if using wants to interact with this particular thing, and it can send this particular thing a bunch of different commands. But the question is, which thing can be sent which commands? And the question 2 is, which of these things are connected within which different things? And maybe another thing you want to do, let's say, maybe you want to be able to say some commands to hold rooms. Okay? So then is the question, what does that mean? Does that mean, can you send the command, is that what it's, what is that called? So is the commands that are sendable to the room the union of all commands sendable to all devices within the room, or is it the intersection of all the commands? So in other words, if there's a single, if you have a room of lights and one refrigerator, can you send the refrigerator commands to that room? Or can you only send the things that are common between the refrigerators and lamps, such as, for example, power, so on? Probably it's union of sense. If you say, well, I'll send the command to the room, and I will just send the command up to anything that's operable. And it's not only that, probably you can figure out how to sort of build upon this structure to reach something really pretty cool. And I think that would be pretty cool. Okay, so in the interest of time, I've gone way over time. So we're not going to talk about senses, but I think similar kind of network, but it's not about commands. It's like there are a bunch of sensors that are distributed across different rooms, and you want to be able to listen to updates from the sensors, but each update might have completely different structure. It's something similar to this, right? Where it's like, well, I sort of look at this right now, because this is very found this immediately, but I should see that there's a bit of complexity that you can definitely, where that seems very interesting to unravel. But what's also sometimes needs to be spent on the sensors as well. But there's the sensor data. The sensor data is like the thing that's common across all of them, which is probably not a lot, which is like on the device data. The thing that we found that was the same across all devices is nothing more but the ability to get factors or to get commands. So that's not a lot. So probably the sensor data will not contain a lot. But let's think about how these things interact so that yes, it's already going to now. And anyway, probably it's not the same. You probably need to think about something like this and all this. It's not a inherent priority, right? It's more like motion sensors are sensors that can provide sensor data. Motion data. Thermometer is something that can provide a temperature data. But like let's say refrigerator could provide temperature data. Maybe a lamp could provide temperature data. So you're standardizing again. The question is, I guess, always like, are you grouping by kind of thing, or are you grouping by capability? We shouldn't look for grouping by capability because we're not sure about the source of list of possible devices in the future, nor about possible sensors in the future. So if we can get some usability going, that would be fantastic. So probably something along those lines. Well, a sensor is a sensor that can provide a set of different sensor data, or different types of sensor data, right? So whenever you ask motion sensor for data, or whenever you ask the sensor for data, it really doesn't provide a single class of data. It really provides a collection of sensor data of different types. Where it's like, so maybe you get some, let's think about the map, right? Maybe you get some color data, and you get some heat data, some temperature data. But it's not, I'm going to let it go because clearly I haven't focused on it. It's not obvious because then you have a collection of things that are different, and then maybe we start to get into a scenario where we visit how to recover the best type of information. So we should maybe think about that a bit more carefully. And maybe I can start with this question. I'm going to ask myself, what am I going to use this sensor data for? In what context am I going to use it? So actually, research it's going to display / analyze. Right? So, let's do that. We should think about this. Possibly draw some points from this discussion. Anyways, let me wrap this up. Even if I was try to relate to this answer again, massive bullshit. I hope this helps, and thank you. This is a super interesting excursion. And best of luck with the application. I hope it works out. Thanks for the question, and I'll see you around. I came across this super interesting blog post about a concept the guy calls message obsession. So it's a code smell that the guy claims to have invented. He puts it in contrast to the code smell primitive obsession. So he's saying if you're pushing primitive obsession too far, you may end up with message obsession. And actually I think the concept makes a lot of sense. If I'm understanding what he means with message obsession correctly, I can definitely relate to having sort of performed the sin and having had the realization. I vividly remember having at some point during my journey to programming come to the realization that I'm being obsessed with creating specific names for things. Let's talk about what he means with message obsession. I'll ruthlessly steal as examples on that price. I hope you don't mind. I can link the article below, so please do check out the article. So here's the example. Let's say that you have a system where you have a robot. You're making some kind of game, and then you want to move the robot around. So you have an instance of a robot, and you want to be able to send messages to the robot to make it move east or west or north or south. So if you're being obsessed with primitives, perhaps what you would do is that you would have a move method on the robot. And then when you call the move method, when you send the message move to the robot, you pass two arguments, an x coordinate and a y coordinate, an x and a y. So as in, if you would send 2 as x and 2 as y, you would move horizontally 2 units and vertically 2 units. But of course, as you can see, this is evidently primitive obsession because the domain concepts are sort of hidden. The domain concepts are sort of implicit rather than explicit. By the way, please see my other video on primitive obsession if you're not entirely sure what primitive obsession is. And what I mean when I say that the domain concepts are implicit, I mean if you pass a positive integer for x, for example, it's not obvious whether that means right or whether that means left. Is positive right and negative left, or is positive left and negative right? While you may argue that some choices are more reasonable than others, or it's still obvious that there is a matter of interpretation, that somebody could have a different interpretation, and that there thus is information that is implicit rather than explicit in your program. So to combat, what you might do is that you might create 4 methods of the robot. Move west, move east, move north, and move south. And yeah, that might be better because you've made information explicit. Absolutely. But there's still some problems, and I think the article puts it very nicely when he exemplifies by saying that this encourages you to use conditionals. It encourages you to use conditionals because you have named methods that you in other places will have to call. So let's think about it. Dynamic dispatch. You can't change a call to west, to east at runtime. You have to change the call at compiler. And if you want to change it at runtime, you have to somehow switch over something and then either call west or call east. A proper solution, or a more proper solution to this problem, he argues, would be to make heavier use of composition. So in other words, to have some kind of direction class, instantiate a direction object, and then pass that direction object to the robot's walk method. So you have the walk method, it takes a single argument, and what you're supposed to pass it is an instance of a direction. So with that, you eliminated primitive obsession, and you increased composability, but you still have the ability to name things, because you can still save a direction into a variable, and thus give that variable the name move west. And you save another direction into another variable, and name that variable move east. And through that, you've almost achieved the same explicitness as you had in the example where you had explicit methods named move west, move east, move north, and move south. But you also have very high composability. So I think this is an excellent blog post, and I highly recommend you to go read it. Because as I said, I really saw myself, as in my early days of programming, exercising this kind of behavior. And depending on where you are in your journey as a programmer, I guess it's kind of likely that you too recognize yourself. Very early on, from my experience, it seems that programmers realize that there's tremendous value in making things that are implicit, explicit. It's much easier to communicate the intent of the program when you have proper names for things. But in our efforts to name things, when we are creating methods that encapsulate behavior that are non-composable, then we're trading in a lot of flexibility in exchange for that explicitness. And if we instead learn to write code that is highly composable, we can achieve high composability and still make things explicit rather than implicit. That's it. Thanks for watching. Remember to subscribe if you want more code talks like this. I'll see you next time. Let's talk about primitive obsession. We previously touched upon primitive obsession, but we haven't really dug into it in detail. So primitive obsession is when we're using primitives to represent domain concepts, domain ideas. We'll talk about examples, but let's first talk about it on sort of a general level. So let's start with the question, what is a domain concept? A domain concept is an idea that belongs to the context of your application, that is specific to your setting. So if you would be building a boat, for example, then a domain object, a domain concept could be a post, it could be a comment, it could be a statistic, such as in how many comments are there on a particular post. And if you build a library system, say, it could be books, authors, and so forth. I think you can see what I'm saying. So now we know what domain concepts are, but we also need to know what primitives are. So primitives are usually things such as ints or floats, bytes, characters, right? These very primitive data types. And in some languages, strings. But in some languages, strings are not actually primitive data types. Now, when we say primitive in primitive obsession, my understanding is that we include things such as strings. In Ruby, we include things such as hashes. In C# we include things such as the dictionary. This is open for debate, and there's a whole lot of nuances here, and I can see how it could be valuable to hold the other position, to say that primitive obsession only apply to actual primitives. Because, for example, because hash in Ruby is an object, you can actually inherit from hash. So some of the problems with primitive obsession disappear in a language such as Ruby. So now we know what primitives are, and we know what the main concepts are. So let's think about the definition again. So the definition said that primitive obsession is when you are using primitives to represent the main concepts. So let's exemplify. Let's say that in our application, for some reason, we want to have ages. So we want to be able to represent the age of a person. And for the sake of example, it's actually important that it's an alive person. So it's not about representing the age of a historical person that lived thousands of years ago, but calculating that person's age to today. It's not about that, right? It's about representing the age of individuals that are actually alive today. If we would represent the age with, say, an integer, then we are exercising primitive obsession. We're exhibiting primitive obsession. We are being obsessed with primitives. Think about it this way. What is the domain of possible values for integers, and what is the domain of possible values for age? If we use ints to represent ages, then suddenly anything that is a valid integer seems to be a valid age. But that's not actually true, because an integer could be minus something, but it makes no sense for an age to be minus something if we're only looking at live people. If this kind of domain type of thinking, or range, or set of allowed values, if that sounds confusing, I highly recommend that you check out my other talk on list of substitution principle. It's very closely related to that. It's about thinking, I have this class, what are theoretically all of the possible configurations, all of the possible instances that I have in this class. So in this case, if the range of possible values in integer differs from our domain concept, then we are creating problems for ourselves, and this is what primitive obsession is trying to warn us about. Because suddenly we have a variable that will contain an age, but we can't be sure that that age will adhere to the constraints of ageness that we have in our application, that's inherent to our domain concept. So something that I find particularly interesting about primitive obsession is that it's not immediately obvious that primitive obsession is a bad thing. Before I first learned about primitive obsession, I believe I thought that making use of primitives, or prioritizing the use of primitives over complex objects, is a good thing, simply because primitives have these dependencies. If you think about it, right? I mean, depending on a primitive, having a method that depends on a string feels less heavy than having a method that depends on some kind of complex object that you built yourself. If you're accepting something of a type, then you need to know about the existence of that type. And it's very devious. If you think about the saying by Robert C. Martin, good architecture is to maximize the number of decisions not made, then not introducing another type, not introducing another class, but rather making use of a string or an int to represent something as a postal code or a phone number or a name or anything like this, may spontaneously feel like a very smart decision because you are deferring the decision. You are maximizing the number of decisions not made because you're not making the decision right now. You are simply coupling to a primitive, and you then still have the choice of introducing a complex object in the future. But this is not entirely true. And now we've only talked about what seems like a benefit in terms of a string or an integer being less of a dependency than a complex object. But there's also the concept of that if you depend on a string, then that string can't have internal dependencies. But if you depend on a complex object, then your complex object might actually have other dependencies. So when you depend on a particular object, a particular class, if that particular class has other dependencies, They may have the dependencies that may have other dependencies and so forth. So when you're depending on a particular class, you may in fact be depending on a whole series of classes, of tree of classes. So again, from a purely theoretical point of view, from a purely intuitive point of view, it seems that depending on a primitive is actually a good choice, because you're reducing these dependencies. You're eliminating the possibility of depending on trees of complex objects. But as you may have guessed, of course, this is not the full story, and thus primitive section. So here's the problem. The problem is that by coupling to a primitive rather than a complex object, you haven't actually eliminated dependency. You have hidden the dependency. You have made dependency implicit rather than explicit. So the dependency still exists, but it's not immediately obvious to other developers or to yourself in some period of time, whether at any given point in time the dependency is met or not, whether the constraints are satisfied or not. And from a machine point of view, the compiler or the interpreter can't know. So if you think about a typed language, for example, you can't know whether you've satisfied the dependency from a type perspective, because as long as you pass it a string or an int or whatever you chose in the scenario, the compiler or the interpreter would say that it's okay. But it could of course be that your string or in this particular scenario wasn't actually a valid name. And this is where the key lies. So again, think about the domain of possible values, the range of values that are allowed for an object, for an instance of a type at any given time, right? Given some time. So let's say that we are talking about ages, for example, in the previous example. Ages of people that are alive. If you model age as an int, then any number that is a valid int should be a valid age. But if your domain says that, okay, actually ages in this system, in this particular location, can only be positive and say below 120, right? We're taking it to the extreme. But then we have constraints. We have a range of allowed values. That means that all integers that are outside this boundary, they aren't actually valid ages, but they are valid integers. So in other words, integers are not a valid proxy in this case for ages. And I'm not going to go into details about how this can cause problems, because I guess you can probably see how tons of inconsistencies very easily can occur, because we are passing around something that's checked against one set of requirements, but should be checked against another set of requirements. We're passing around something under the mantle of being an int, when in fact we should pass it around under the mantle of some more tighter constraints. So probably this kind of thinking could be used to determine whether you are primitively obsessed. I don't think that's the way to say it. But so let me put it in completely different words. If I'm pondering whether I should put something in a class, whether I should create a class or something, make it an object, and use it as an object, or whether I should use a primitive, let's use that test. Are all the values for the primitive valid values for my domain concept? I have this domain concept, say age, say name, say something completely different, and I ask myself, are all possible strings, ints, hashes, etc. valid instances of this domain concept? But as always, this is of course one perspective. You could actually argue the complete opposite of what I was arguing before about primitives being used to defer decisions being made. You could of course argue that primitives make it more difficult to change your mind later. In that case, even if the domains of primitive and of the domain concept have the same ranges, even if you, given that rule, could use a primitive, so the primitive would be a valid substitute, completely okay type to use instead of, then one could argue that you should still not use primitives. Again, based on that, if you have a class, it's easier for you to substitute that object later on. It's easier for you to change your code without modifying your code, without editing your code. Let me be more precise. It's easier to change the behavior of your program at runtime without changing it at compile time. So it's easier for you to, without rewriting your program, rewire your program. In other words, send different objects to different locations, and therefore, or thereby, change the behavior of the program. So if you use that kind of logic, I guess the conclusion would be, if you have any reason to believe that your domain concept will require more complex logic in the future, or will for some reason change its range of valid values in the future, then the cost of extracting a class, the cost of creating a class and using that class to represent the domain concept is so low that it's silly not to do it. And I think there's a lot to that argument. But to sum up, what we indeed can say is that if the domains are different, if the domain of valid values for your domain concept differs from the primitive that you have in mind, differs from the domain of valid values of the primitive that you have in mind, then using that primitive would be exercising primitive obsession. So in that case, you need, in an object-oriented language, a class. That's it. Thanks for watching. Remember to subscribe, and I'll see you in the next one. Today I want to quickly talk about command query separation in relation to events. I've done a previous video on command query separation, so if you haven't checked that out, be sure to check that out. But very shortly, command query separation is about separating your methods that perform commands from your methods that perform queries. Any method that mutates state is a command method, and any method that returns a value is a query method. So command query separation asks you to separate these two so that some methods are not both commands and queries. In other words, they are not mutating state and returning values. To really get a quick grasp of what it's all about, think about this quote. It was formulated by the person who formulated command query separation. Asking a question should not change the answer. But there are some edge cases that make separating commands from queries difficult. One famous example is a pop method on a stack. So if you call pop on a stack, you remove the first element, but you're also returning that first element. So in some sense, you're performing both a command and a query, and then in some sense, you're then asking a question that does change the answer. But let's back up and talk about a simpler scenario. Imagine that you have an instance of a user and you call save on that user, and then imagine that when you call save, that user is then saved to a database or to memory or whatever. Essentially, it mutates some kind of state, but it does so synchronously. So in this hypothetical example, when we call save, yes, the user saves, but also if the user was unable to be saved, you get an error message back. So in other words, imagine then that you want to do two things. You want to save the user, i.e. mutate state, i.e. command, but you also want to know whether the save was successful. You want to return something, i.e. a query. So let's say that would be returning a boolean, for example. That would be a trivial scenario. If we make the scenario a little bit more complex, then you could say that you, instead of getting back a boolean, you get back a string that contains the error message, right? So it's kind of obvious that we're doing two things. We're saving the user, but we're also returning some kind of value that describes whether the save of the user was successful or not. So if you think about that, the scenario is actually very, very close to the pop example, the pop on a stack example. It's essentially the same problem. Instead of doing two things, we are doing both of them at the same time. So I found a very interesting Stack Overflow post on this particular topic, and I'll make that in the description. An obvious way of mitigating this problem is, of course, to mutate the user object with whether the save was successful or not. But that just doesn't really feel right. I can totally relate to that feeling a bit awkward, right? Because then you call save on the user instance, and you mutate the user instance to contain whether the user was saved or not. So when you then want to make a decision further on, you would have to inspect the state of the user in order to determine whether to try to save again or change some kind of value of the user, or whether it actually successfully saved. But to get the point, essentially, events are another way of trying to mitigate this issue. So just as a parenthesis, of course, there are many, many ways of solving this scenario, and there are many ways of solving this problem that does adhere to command query separation. Events is just one example, but I find it particularly interesting. So let's talk about observer pattern rather than events, because I think that's sort of a more universal way to talk about the same concept. So observer pattern or events essentially sort of invert the control flow. Instead of pulling data, you push data. Right? Instead of clients pulling data from a server, the server pushes data to the clients. So observer pattern in a nutshell, remember, observer pattern consists of a subject that can be observed, in other words, observable, and a bunch of observers that register to the observable, and then are notified whenever the observable undergo changes that the observers might be interested in, right? Same thing as events, right? You register an event handler that listens to a particular event. So when an event occurs, you want that particular procedure or method or whatever to be called and executed. So if you think about that, right, that inverts the control flow in the sense that instead of checking and asking whether it's time to perform something, you let the other person, you let the server, you let the other thing determine when it's time to call that particular procedure. And if you sort of think about what that means that we move from a query to a command. And that's the essence of trying to use events to adhere to command-query separation. So in the particular scenario we talked about before, the user, this is what we could do. We could move to events and push commands rather than pull data through queries. So if we, before we call user.save, register an event handler, or in the case of observers, registers an observer that observes saving of, say, users, or hypothetically something more general. But essentially you register an observer that is interested in knowing whenever something was saved. Or if you think about error handling, that gets notified whenever there was an error trying to save something. So this means that when we call save on the user, we don't actually have to get a value back, right? We just send a command, save this particular user, and if that saving for some reason fails, then that save method can simply dispatch an event that says that there was an error saving this user, right? So instead of returning that back, right, instead of turning the method into a query, we keep it as a command because it dispatches an event that says there was an error saving this particular user. So it dispatches a new command, right? So it's a chain of commands. So that's why I say it's inverted, right? So instead of calling the method and getting a value back, right? We call the method and dispatch another event that invokes a method in place where we can handle the fact that some users are saved and some users are not saved. Or we can handle the fact that sometimes we get errors when we're trying to save users. So to sum up, the key lesson is, when you have something that is both a command and a query, and you want to adhere to the command-query separation principle, perhaps what you can do is to dispatch an event rather than to just return a value. In other words, removing the query portion from your command query and simply turning it into a pure command that dispatches another command, i.e. dispatches an event that somebody else can listen to and act upon that. And I hope you can see how this can be used to solve the aforementioned problem on a stack. Thanks for watching, and I'll see you in the next one. You've probably heard that you should not mix object construction with object use. In other words, that you should not mix the creation, the instantiation of your object with the business logic operating over these instantiated objects. Or in other words, that you should not mix the creation of your object graph with the application object. Now, why is that? Here's the thing. It's really just another way of talking about dependency inversion. In the words of Bob Martin, a good architecture maximizes the number of decisions not made. In other words, the longer you can defer a decision, the more you increase your chances of making the right decision. If you choose the wrong decision and then build your application towards that, you might have to incur a lot of cost when you want to change that later on. So when you are focusing on building objects that use other objects rather than create other objects, you maximize the chance of being able to reuse these objects. Let me be very specific. If you have an object that creates other objects and then performs some action upon that object, and then you later realize that the object that it creates is not necessarily the object that you want to have created. You want to change your mind later. Then you simply have to go into that class and change the type of the object being created. But if you, instead of creating that object within the object, you would instead take an object as an argument, i.e. dependency injection, then that increases the chance of you still being able to reuse the first class. So when you want to take a different object, you can simply then pass in the new type of object, and you don't actually have to change anything within the first class. To give a very concrete example of when this might be useful, think about testing, for example. So when you are unit testing something, you want to unit test it in isolation. In other words, you don't actually want to care about the dependencies of the things you're testing. But if you are creating objects within an object and you want to test the outer object, then you can test the outer object without also instantiating the inner object. In other words, the object created by the outer object. But if you're using dependency injection, if you are not mixing object use with object creation, then you can suddenly test those things, because you can inject mock members into the outer member, and since it's not actually creating any new members, you can test the outer object into isolation. So remember, don't mix object creation with object use. Or in other words, don't mix the instantiation of objects with the use of objects. Or in even other words, don't mix the creation of your object graph with the usage of your object graph. Or in other words, don't mix instantiation of objects with the business logic of your application.
Hey, you think I'm doing wrong with this exercise right now? Take a closer look. This is the plank, palm exercise, and other than wearing dances or short blue micro.
I've done a previous video talking about why type checking is considered. Considered a code smell. But I just wanted to give you another very quick reason for why that is. When you are type checking, you are switching over concrete types. And when you are switching over concrete types, it means that if you would want to introduce another type in your system, and if that type also could occur in the place where you are switching, then that means you need to also switch over that type. I think Sandy Metz puts it quite well, and she says that conditionals breed. If you have one conditional, you can be sure that that conditional will cause more conditionals in your code, which is why you should be wary of conditionals. But beyond conditionals, hard coding concrete types in your system makes it difficult or more difficult to change to other types in the future. So the problem is that we don't necessarily know what types we will need in the future. So if you're in a particular place in your code and you switch over types, you have an instance and you switch over the type of that instance, then you need to be absolutely sure about all of the potential possible types that that instance could be of. And of course, because systems usually undergo massive change, then it's reasonable, it's completely sensible to expect that the types of that instance could possibly be different in the future. And I think that kind of sums up the problem of type checking very nicely. When you're type checking, you are coupling to concretions and not to abstractions. And coupling to concretions is less flexible. And in software, we of course want to embrace change. We know that we will often inevitably have to accept change, so we should stay flexible so we have the chance to encompass the change. So type checking is bad because we are coupling to concretions rather than abstractions. So don't ask things what they are, simply send messages to them. Type checking is a code smell.
Question: would you build a website for a major brand With more than 200 million users using web.
If it quacks like a duck, it is a duck. This is one of these phrases people tend to throw out and then make everybody else confused. Let's talk about duck typing. So I can't give you the down depths of what it theoretically means. We'll talk about that in another video, but generally speaking, duck typing is about determining the suitability of an object based on what it does rather than what it is. To be even more specific, whether a method can pass a specific object, i.e. whether the object is suitable as an argument for the method, is commonly, or in a non-dynamic language, determined by the type of the object, i.e. what type the object is of, i.e. what it is. But duck typing says, actually, what does it matter what it is? Let's instead determine whether the object is suitable or not based upon what it does, i.e. what methods it responds to. So in other words, if a method takes an object and then calls the method quark on that object, then as long as the object responds to the method quark, what does it matter whether it's a human or whether it's a duck? Right? The common example is a human pretending to be a duck but still responding to the quark method. An interesting parallel I find is to consider the Turing test. You know, the test for artificial intelligence. It seems to me that the test is about sidestepping the question of what is human, because it's philosophically difficult. So instead of attempting to answer the question of what is human and what is not, the question is sort of restated, or the experiment is designed in such a way that that question is ignored. So the Turing test seems to provoke the question of that if something behaves human, what does the question of whether it is human or not, what does that question matter? If it behaves human and you can't distinguish it from an actual human, then what is really the question of whether it's human or not? Now, this is of course almost a kind of far-fetched analogy, but really I find it quite suitable for duck typing. Because duck typing does the same thing. It says, what does it matter what something is? The thing that does matter, how you want to use that object. And if that particular object does in fact respond to all the methods that you want to call upon it, what does it then matter that it is not stated to be all the type that you expected it to be? So, very practically, what does this mean? This means that in dynamically typed languages, like Ruby or JavaScript or whatever, in these languages, you are not specifying the type of something. So when you're constructing a method, and the method takes an argument, you are not stating explicitly, you're not telling the compiler or the interpreter what that method is expecting, what the method is expecting in terms of the type of argument. You're simply saying that it wants to receive something, and then you go about calling methods on that thing that it accepts. So that means that when you are receiving that concrete object as an argument, you are expecting it to behave according to some particular specification. Or put more lightly, you are expecting it to respond to a certain set of methods. So from a very pragmatic point of view, we could then say that duck typing is really nothing more than polymorphism without a hierarchy. So it's dynamic dispatch without an inheritance hierarchy, or without explicit interfaces. So in other words, in a statically typed language, such as C# or Java, I'm now ignoring the keyword dynamic, but classically, in a statically typed language such as C# or Java, in order to achieve dynamic dispatch, i.e. call a method on an object whose type is not known at compile time, or I should say whose subtype is not known at compile time, essentially you have to either create a common ancestor or construct an interface. You have to somehow explicitly tell the compiler that you are expecting something that adheres to a specific specification, right? To a specific interface that responds to a certain set of methods, and then you can treat it as such. So, returning to a classical animal example, right? You would say that your method takes something of type animal, and then you would have children that are subclasses of that parent class animal. So you could have lion and cat and dog, and consequently that means that the method that takes animals can also take lions or dogs or cats. But returning to the concept of duck typing. So duck typing says that it doesn't matter whether a lion is an animal or whether a cat is an animal. What matters is that it responds to the methods that we want it to respond to. So in dynamic language, you can pass any object anywhere, and if the object does respond to the methods that you don't want to call upon, then that object does pass the duck test. In some sense, then, it is a duck because it per se did respond to methods that make it a duck. And so to push this one further and think about the practical consequences of duck typing, people argue that you should not perform type checking. Type checking is in many senses considered a code smell. We'll talk about that in a separate video. But assuming that you buy that, that has interesting consequences for duck typing. So because in dynamic languages, you don't know what the type is of things that you are receiving. And it may be, at runtime, it may prove to be of any type. So how to make sure that you're not calling methods on, or that you're not calling quark, for example, when given something that is not a duck. So naively, we oftentimes resort to type checking. But the strong followers of duck typing, the way I understand it, would instead argue that you should not check for what something is, that you should check for what something is capable of doing, if you should check at all, assuming that we need to determine whether we can perform some particular action on some particular object or not. So you should check for that capability, and you should not check for the type, knowing that that type does have that capability. To understand this, let's consider an analogy. If you're familiar with the concept of responsive web design, you've probably already come in contact with this concept of not trying to determine what something is, but instead focusing on what something is capable of doing. So in responsive web design, the idea is that there are so many devices out there. There are cell phones and tablets and computers and tons of different browsers and different versions, and like they're just accumulating as the years go by. So the point is that instead of trying to check in which particular environment your application is running, right? The argument is that that will bring you down the path of madness because there are just so many. So you're just going to have to create more conditionals and more conditionals and more conditionals and keep on checking for different types. So the argument is that you instead should be checking for capabilities. So instead of determining whether the environment you're running in is on a browser, for example, because you have some knowledge about what that particular browser does or does not support, you should instead check for the capability of performing the thing that you actually want to perform, and then making a decision based on that. So similarly for duck typing, instead of switching on a bunch of types that may or may not hit your application at that particular point of the code, you should instead switch on the things that you are actually aiming to use, if you are intending to switch at all. In order to nail this down one last time, the concept of duck typing is do not use information about what something is in order to determine suitability for a particular purpose, but rather to use capability as a way of determining whether it's suitable or not suitable for performing that particular purpose. So that's it about duck typing. If you find my explanation completely and utterly confusing, please do let me know and we'll dig further into this. And as usual, if you want more programming talks like this, be sure to subscribe.
So I've got my essay written, and I've been working on it for about a week. So now I'm going to show you how I use grammar with it.
So I did a previous video on why you should be wary of using the static keyword. Naturally, I'm amongst many others that have this opinion, but even though some people find it slightly controversial. And since then I've had a few discussions, it has come to my attention that some argue the need for, or the usefulness of static functions because they argue they move towards a functional style of programming. In other words, the argument is that static functions resemble functional programming. I think this is a fallacy, so let's talk about that. So the argument is that static functions are actually not like functional programming. Let's dig into this. Functional programming has many important concepts. Two of them are that functions are first-class citizens and that the functions are higher order functions. So I'm not at all an expert, but the way I understand it, it seems to me that functions are first-class citizens and that functions are higher order are sort of two sides of the same coin. They're sort of the same thing. Higher order functions is a mathematical concept, whereas functions being a first-class citizen is a computer science concept. So concretely, functions as a first-class citizen essentially mean that you can create a variable and create a function and reference function in the variable and then pass the variable around. Higher order functions, on the other hand, the mathematical side, very simply means that a function can take a function as an argument and or return a function as output from the function, or as a return from the function, essentially. Which is actually not strange at all. So if you think about the function map, right? When you have a collection and then you map a function over that collection, that's an example of taking a function as an argument. Conversely, if you think about the concept of partial application, if you think about curry, that's an example of returning a function. We won't dig into what these specifically mean, but essentially, if you're familiar with these are examples of taking a function and returning a function. So that's higher order functions. Now, returning back to the topic, the point I want to emphasize with the previous video where I argued that you should be wary of using the static keyword is that the problem of using static is that we are coupling to implementations and not to abstractions. Instead of painting this picture as a problem, let's paint this as an opportunity. What we want is that we want runtime substitutability, essentially dynamic dispatch. We want to be able to call a method without knowing which object the method decides. Writing flexible code becomes really tricky otherwise. So such a concept is easily supported if you're in a language where functions are first-class citizens or higher order, because you can construct functions that take functions, which essentially mean that you can exchange the function, i.e. the implementation, at runtime. Static functions, however, does not work this way. Static functions, generally, you can pass around. So I would even go as far as to say that not only are static functions not like functional programming in style, but actually, I think they're less like functional programming than if you would do classic object orientation. Because in classic object orientation, you have polymorphism, you have interfaces. So if you think about it, if you construct an interface that only has one method, and then you have another method that takes something that implements that interface as an argument, then essentially that's like passing a function. Not really, but almost, right? Because then you have substitutability at runtime, right? You have polymorphism at runtime, which you don't have with static functions. So again, functional programming is fantastic, but the argument against static functions have nothing to do with functional programming. So whenever you find someone arguing that you should move towards static functions because it's more like functional programming, please give them this video. Because there are many good reasons to believe that they're actually not. I hope this helps straighten some things out, and if you want more programming talks like this, be sure to subscribe. Good. You've probably heard that type checking is considered a code smell. In other words, type checking is something that you should avoid in your program. And when I say type checking, I mean switching over what type something is. In other words, asking an object what type it is of, and then making a good decision that's different depending on what type the object actually is of. Let's talk about why that is. So the answer depends on whether you're in a statically typed language or a dynamically typed language. Let's first cover dynamically typed languages because the answer is really simple. In dynamically typed languages, you should simply not be type checking because in dynamically typed languages, you should use duck typing. If you're not familiar with duck typing, I've got a whole other video on duck typing, so do check that out. Now, let's talk about statically typed languages. You should not be performing type checking, because if you're performing type checking, that means that you at some point lost track of what type an object actually is of. Let me repeat that. It means that you at some point in your program lost track of what type the object that you want to use actually is of. So what that means? That means that you at some point actually known the type of the object, but you've abstracted in a strange way, which means that you've now lost track of the type of the object. Looking at it from a different perspective, consider this. every cat is an animal, but not every animal is a cat. So in other words, what happens is that you're asking an animal whether it is a cat, which of course is understandable, because if you want to treat it as a cat, you don't want to treat it as a cat in case it's a dog, or something totally different. But the point is that at some point you did actually know that it's a cat, and you've lost track of that, and so now you only know that it's an animal. To really drill that point in, think about static typing. If you're switching over the type of something, you're not actually asking what type it is of. You are asking what subtype it is of. Because the fact that you have that object in that particular place in the program anyway, means that you have some type of information about the object. In other words, you can't just accept anything unless, of course, you're accepting super general types in your programs, such as object, but then you're not really using the concept of typing to your advantage anyway, and that's a whole other question. But in other words, in your method, you've accepted a base type, and now you're switching over which subtype of the base type this particular instance is of. So, that means that you did, in fact, because it has been instantiated, you did, in fact, at some point in your program know what particular subtype this thing was of, but you've lost track of it. Okay, I'll stop ranting now. I currently really believe that there are no cases where you actually need to switch over types. Again, because if you are switching over types, it just means that you've architectured your solution incorrectly. It doesn't mean that the program necessarily leads you to switch over types. If you have an example of some particular tricky scenario, please feel free to outline that in the comments, and let's discuss that. But that's it for today. Be sure to mash that like button if you like the video. If not, please let me know why in the comments. And if you want more stuff like this, be sure to subscribe.
Hey, you see what I'm doing wrong with this exercise right now? Take a closer look. This is the plane. Connected.
Let's talk about replacing conditionals with polymorphism and primitive obsession. Or expressed in a different way, the limits of replacing conditionals with polymorphism. In other words, as far as I understand it, it seems that it's not always possible to replace conditionals with polymorphism. Let's talk about when that is. But let's first make sure that we are on the same page with the concepts. So, replace conditional with polymorphism is a phrase that was popularized by Martin Fowler in his great book, Refactoring. As a programmer, I find that this book is one of these go-to books that every programmer must have. I've linked it in the description. Be sure to check it out. Moving on. So yes, the term is popularized by Martin Fowler, but what does it actually mean? Let's break down the statement. We're talking about replacing conditionals with polymorphism. This means that we need to understand what conditionals are and what polymorphism is. Conditionals are if statements, switch statements, etc., etc. When you're switching, right? When you're saying that there are multiple paths through this program, when you're making a branch in your code. Polymorphism, on the other hand, polymorphism is, if I'm not mistaken, a way of achieving dynamic dispatch. By example, it's when you have an animal as a superclass, or as an interface or an abstract class, and then you have a cat and a dog, both inheriting from animals. The point being that the rest of your code can then couple itself to animals, rather than to concrete cats or to concrete dogs. So you couple yourself to a superclass. You couple yourself to interfaces rather than concretions. But if you're watching this channel, I'm pretty sure you're already intimately familiar with polymorphism, so let's move on. The point here is that we're saying replace conditionals with polymorphism. So every time you have a conditional, you should replace it with some kind of polymorphism. The easiest way to get it is probably to think about the example given by Martin Fowler. Right? I think that in the description. But essentially, the part where he replaces conditionals with a polymorphism is that he has some kind of movie database system and he gives genres to movies. So he puts enums in the movie class. So he has a class that represents a movie, and a field in the movie class is the category of the movie or the genre of the movie. And instead of having some kind of class, he simply uses an enum or an integer or something like this. I can't remember, but essentially some kind of primitive or primitive-like thing that represents the category that that movie belongs to. Actually, when I think about it, it's actually not genres, but it's something like genres. But whatever. Essentially, the point is that he starts out with this as a field and then moves towards instead making multiple types of movies where the movie type represents what kind of genre it is. Again, I'm saying it incorrectly about saying that it's genre, it's actually genre, but I think you get the gist of it. The reason we're saying replace conditionals with polymorphism is that when we are now grabbing out something or calculating something that depends on what type or genre of it is, instead of switching, instead of reading this enum or integer or whatever it was, reading this primitive and then making a decision based on that primitive, we can simply dispatch into the class, and then because of polymorphism, depending on which actual concrete type it is of, you can calculate different things. I'm probably making it overly complicated when I talk about it like this. If you just think about it, it's actually super trivial. If you have dog and cat and animal, and if cats and dogs override the speak method from animal, then if you're passing around instances of cats and dogs, mixing them, but refer to them as animals in your code, then as soon as you call speak, you will call the method on the cat if it's a cat, and you will call the method on a dog if it's a dog. Essentially, dynamic dispatch. So now we've handled what replacing conditionals with polymorphism is. So before we dig into the limits of that, let's first talk about primitive obsession. So primitive obsession is the phenomenon where a programmer is overly committed to coupling to primitives rather than complex objects. So again, let's define, right? Like, what are primitives? Obsession I won't define because I think you can figure out what that means. But primitives essentially are things like ints, floats, numbers, in some language, strings. But so what does primitive obsession mean? So primitive obsession means that a program is overly obsessed with passing around primitives rather than passing around objects defined by the programmer. So instead of passing around said animal, for example, and then calling speak on that instance, for example, I may be first extracting the string of what the animal says and then pass around that string. So in some oversimplified sense, it's a way of extracting data out of objects, extracting the primitive data out of objects, and then passing around that instead of passing around more complex objects. We'll talk more in depth about this phenomenon some other time because it's super interesting and there are some nuances, and one could ask why this perhaps isn't a good thing because primitives should probably have less dependencies. But it's not as obvious as one might think. Let's talk about this some other time. But essentially, here's where I want to end up. Primitive obsession may seem like a good thing at first, but when you start to think about replacing conditionals with polymorphism, you'll realize that you can't replace conditional with polymorphism if you have primitives. You can't use polymorphism if you have primitives. So essentially what you're doing is that you're forcing yourself into a place where you have to switch, where you have to use switches, where you have to use if statements, where you have to use conditionals in order to handle the branching of the program. Instead of, if you had objects, you could use polymorphism, which in many ways is a much more sane way, a safe way to handle switching, to handle conditionals in your program, or rather to handle branching in your program. So what I find super interesting about this is that after having been a fan of replacing conditionals with polymorphism for a while, I started to think that actually, maybe we don't even need conditionals at all, because we can always replace conditionals with polymorphism. And actually, if I'm not mistaken, the object-oriented language Smalltalk doesn't even have the if construct. Now, Sandy Metz shows in another talk, I've linked in the description, that you can use other constructs of the Smalltalk language to build what's essentially an equivalent of the if construct. But again, it's kind of a thought-provoking idea to say that actually the language doesn't need a dedicated construct for conditionals. But here's where it gets interesting. I like to think of this in terms of the edge of the application. When we start to hit primitives, when we necessarily have to hit primitives because of the requirements of the application, then we can't use replace conditionals with polymorphism. Then we can't replace conditionals with polymorphism. So at the edge of our application, there is some dirt that sort of necessarily has to be there because we can't encapsulate it into our nice domain object and into our nice domain language. And if you think about it, just let's take a concrete example to make this more concrete. Think about something trivial. Let's say you are building a console application, a terminal application, and the user is prompted to type in a number from 1 to 5. You get it in as a string because it's a terminal application, and you want to take different paths in the program. You want to do different things depending on whether it's a 1, whether it's a 2, whether it's a 3, etc., etc. And if it's something below 1, or if it's something above 5, then that would be incorrect input and you want to do something completely different. So for all of these scenarios, we have different paths through the program. So somehow we need to identify which number the user actually pressed, and then move the program accordingly, or direct the program accordingly. And while I haven't given this deep thought, if you think about it spontaneously, you would realize that, well, of course, you could probably find some kind of way to define that particular domains of numbers belong to a particular type, right? But I'm not necessarily sure how that's better than conditionals, right? As long as you are isolating your conditionals to the edge of the application. So essentially, my point is this, to sum up. If your requirements necessitate the use of primitives at some point in your program, then at some point in your program, you will have to use conditionals. You can't replace the conditionals with polymorphism because the requirement inherently necessitates the use of conditionals. Because we are hitting the edge of the application, we are hitting a point where you get data in a format that is not controlled by you in terms of primitive. And again, I haven't thought about this deeply, but probably this holds for example, API calls as well. This is why I'm saying edge, right? It's not necessarily just the concept of primitives. It probably also goes for exiting the boundary of the application. So interacting with third-party libraries, interacting with the user, etc., etc. As soon as you are leaving the land of your nice controlled code and get into the wild, right, things are structured in a way that you don't have control of, and thus you may be forced to actually use conditions. But as long as we're in the boundary of our own application, I see no reason why we should ever have to use a conditional. I mean, conditional will have to stem from primitive obsession. Finally, before I go, let me just formulate this as a design tip. The way I'm thinking about this is then that if you understand that a particular requirement necessitates the use of a conditional, then you should isolate that conditional in one place, and you should push it as far as possible out to the edge of your application. You should not spread out this conditional throughout, scatter out your conditional throughout your application, and you should not let it sink in deeply into the core of your application, but rather you should push it out to the boundary, right? You wrap it in some kind of wrapper that's wrapping some kind of wrapper, etc., etc. Like, you make sense of the conditional within your own domain language. So to me, this kind of sounds like a way to handle necessary dirt. There's something problematic you need to handle, so you wrap it in something that's nicer and hide it. So you would treat the conditional as a deceit, right? You're isolating it into a particular place of your application, pushing it as far out so that it's not something that you use often, instead of letting it spread out through your application, because as Simon says, conditionals tend to breed. Thanks for watching. Remember to subscribe, and I'll see you in the next one. You've probably heard a lot of people say that downcasting is a code smell. I'm one of those people, so let's talk about why that is. So downcasting is a form of typecasting, and typecasting can roughly be said to be the idea of taking an instance of one type, but treating it as an instance of another type. Roughly. So typecasting is not specific object-oriented languages, but downcasting and upcasting are usually found in languages that support hierarchical data types, or polymorphisms. But before we push on further, let's make sure we are on the same page on what downcasting and upcasting is. So let's do a classical animal example. Let's say that we have an animal superclass and a cat subclass. So cat inherits from animal. So if you have an animal, but you treat it as cat, then that is downcasting. If you have a cat, you treat it as an animal, then that means it's upcasting. So in that sense, it's very simple. Downcasting casts down the inheritance chain, and upcasting casts up the inheritance chain. And up means up towards the superclasses, and down means down towards the subclasses. We'll talk about upcasting some other time. Let's now focus on why downcasting is considered a code smell. So if you think about the animal example that we just talked about, the problem should become quite apparent to you if you just think about it a bit. Think of it this way. In the system that we've designed, every cat is definitely an animal, but not every animal is definitely a cat. Think about it. every instance of a cat definitely has to be an animal. But given any instance of an animal, you cannot be 100% certain that that particular animal is also a cat. Because cat is a subclass of animal, which means that hypothetically, the system could contain even more subclasses that are also animals, and thus we have uncertainty. Of course, in the kind of scenario that I posed, we didn't actually have any other subclasses apart from cat. So in our system, we could, in some practical sense, actually be 100% certain that every instance of an animal would be a cat, for the mere reason that we don't have another subclass that inherits from animals. But remember, as always, we're designing systems, right? We're architecturing systems. And I'm not saying that you should anticipate requirements that you're currently not anticipating. But what I'm saying is that if you use that kind of logic, I think it's fairly certain to say that you're going to be in a world of hurt a lot of times. So let me put it in a slightly different way. In some sense, I'm shocked that the idea of downcasting actually exists in serious languages that we use, such as C# or Java. If there is some kind of rational idea behind this, please feel free to outline that or point me towards some resource in the comments. Because honestly, I really haven't found any good reason, but I may be wrong. However, the object-oriented language OCaml doesn't support downcasting. So at least some people seem to agree with the idea that downcasting simply isn't ever a good idea. And in case I'm underestimating the amount of people that think that, then perhaps we have downcasting in a lot of languages for legacy reasons. Perhaps people, when designing these languages, didn't realize how fundamentally insane downcasting is, put them in languages, and people started using them, and then now we have code bases where people are using downcasting and we simply just keep it there. But I mean, now I'm totally speculating, I have no idea. So with the arguments that we looked at, I'm pretty sure you already agree that downcasting is in some sense kind of insane. But to put one final nail in the coffin, let's look at one more example. Just think about the absurdity of this scenario. Assume that you were building a class, you were writing a class, we're on the same team, you and I, right? And you were writing a class, and in the constructor of that class, you take something that is of a type, say, an animal. But then in your constructor, or later sometime in your code, you are downcasting from an animal to a cat. And then you give this class to you. And if you think about this situation from a contract perspective, right? As in an interface perspective, as in the boundary between me and you. So the way I interface with your code and the way you interface with my code. I mean, trying to find some agreements on interfaces is like 101 of actually trying to produce something useful in a team. So from an interfacing perspective, essentially what you're saying to me is that here's a class, you can use it the way you want, as long as in the constructor you give it an animal, right? What you're saying is that anything that is of type animal is okay. So I make that assumption, right? I take your class, I instantiate an instance of your class, and I pass something that is of type animal to the constructor. But what happens? It blows up. Because in your code, you were downcasting. You were downcasting to cat, and maybe I sent a dog, right? Your contract said you want an animal. I instantiate an animal, i.e. a dog that inherits from an animal. I pass you the dog, and then your code blows up because you were downcasting to a specific type. And then you may come in and you argue, okay, wait, but I could have used this instance of, I could have checked whether the thing I'm passing is of type cat, and only in the case that it is of type cat, then you downcast, right? And you're right that that wouldn't cause an exception, but design-wise, this is insane. I won't dig into this argument in depth, but please see my other video on why type checking is a code scenario. If you think about it, what's happening is that we are breaking the open-close principle. The open-close principle says that something should be open for extension but closed for modification. So your class, through dependency injection, is closed for extension, not only for modification. Because when you are typecasting to a cat, you're suddenly locking me in. You're saying that, okay, if you pass me something that's not a cat, then there are certain parts of the behavior of this class that you won't get to experience because it's only for cats. But that's insane. And the interface should be that you're expecting cats, and only cats, and not animals. So with that said, I'll be quiet. Essentially, my point is this. I don't think there's ever a valid use case for using downcasting. It's just fundamentally insane. The idea of downcasting is completely backward, completely insane. But if you have an example of where it does make sense, please shoot that in the comments and we'll discuss. But please avoid discussions of pragmatism, because if you're arguing pragmatism, then I would spontaneously argue that the cost of not downcasting is so silly low, it is so low that it's just silly to argue that it's pragmatic to use downcasting. But apart from that, if you have any good arguments, I'd love to hear them. That would be fantastic. Anyway, thanks for watching, and I'll see you in the next one. Let's talk about CQS, command query separation. Command query separation is a term first formulated by Bertrand Meyer. Bertrand Meyer is the creator of the programming language IPOS and also the notion of design by contract, which is native in the programming language IPOS. Command query separation essentially states that you should separate your queries from your commands. Kind of intuitive name, right? But what does that actually mean? Let's first get it clear that what we are talking about is methods. In other words, that methods should not mix command operations with query operations. So, command query separation is not a concept that is specific to object-oriented programming. It could be applicable in more paradigms. But what does it actually mean? So, a query is when a method is asking some kind of question. A command is when a method is performing some kind of action. So a query is when a method is asking something and you retrieve a value back from the method. In other words, the method returns something. A command, on the other hand, is when a method performs some kind of action. Let's be less ambiguous. You may already have realized that this is about mutation. So queries do not mutate the state of your application, whereas commands do mutate the state of your application. So in other words, this is about separating the methods that mutate the state of your application from the methods that don't. So what is the point of separating commands from queries? There are probably many reasons, and given that it's originally formulated by Bertrand Meyer, I'm sure there's a smart reason behind it. But one more trivial reason is that it makes it easier to reason about your code. Now, in what sense do we mean that? If you separate the commands from queries, then you will trivially know when you're